Yes, we can start beginning. In brushless DC or AC motor, we have three type rotor. One of them in the left side, surface mounted. Second one, you can see interior rotor type. In this issue, permanent magnets are mounted on the interior side of the rotor. This is called as a rectangular magnets. Also, last one, rectangular magnet inserted into the rotor core. Okay, generally in the industry, we will see three type rotor shape. I said this issue, maybe we can continue with the theory of operation. Actually, it's important for us. In this course, we are focusing the DC motor, MBL DC motor. Actually, DC motor, MBL DC motor, nearly same characteristic. Important characteristic here, torque speed characteristic. Okay. In this figure, you can see an example for torque speed characteristic. There are two torque parameters used to define a BLDC motor. One of them, peak torque, and the next one, rated torque. For example, if you want to design an electric vehicle motor, we need two torque value. One of them peak torque, one of them continuous torque. For example, your electric vehicle goes to high slope degree. You need peak torque. Also, you are in the flat road, you need rated torque. Okay, this is important selection criteria. For example, in your homework, in your midterm and final project, you need to select an electric machine. This issue is very important. Okay, during continuous operations, the motor can be loaded up to the rated torque. Okay, as discussed in the early course, actually last two course, in a BLDC motor, the torque remains constant for a speed range up to the rated speed. The motor can be run up to the maximum speed, which can be up to the nearly 150% off to the rated speed, but the torque starts dropping. This is like an gear ratio in internal combustion engine classical vehicle. Applications that have frequent starts and stops and frequent reversals of rotation with load on the motor demands more torque than the rated torque. These requirements comes for a brief period. Actually, we need the peak torque as a very brief period. Okay, it's important issue. If you select high torque motor for your electric vehicle, probably this will be over design. Also, some acceleration, some high slope steep condition, etc. Actually, during this operation period, extra torque is required to overcome the inertia of the load and the rotor itself. The motor can deliver a higher torque maximum up to the peak torque as long as it follows the speed torque curve. Now I want to show a paper at this point. Let me share files. Yes. Okay. Now This is typical electric vehicle design approach. I want to show you motor selection criteria. Huh. In the bottom of page, you will see, I hope, speed torque curve for selected electrical machine. Okay. You can see here, this my motor is operated in 4,800 RPM, revolution per minute. This is my speed range. Also, I have torque axis. This is my continuous torque operation region. In this period, I need high. Yes, actually, yes, Samar. Actually, yes, an example of your final project. I, actually, it's a good question. Maybe I can explain all side of the final project with this paper. Okay, good question. Now you can see high torque operation region. Here, my motor goes to minimum speed. For example, not highway, not high speed roads, etc. This is only just and only traffic condition, acceleration, starting position, also high slope range. And then my torque goes to rated value. My motor in high speed operation, my rotor turns at the 4,800 RPM. My torque goes to 120 Newton meter. Okay. Okay, it's a good question. I will explain your final project with this paper. Actually, this is a good paper for your operation. In this paper, we are designing an electrical vehicle. Critical value. In first step, we select our parameter. In this example, we want to design M1 type. Also, maybe it's called as a L1 type, small electric vehicle. In the market, we have some examples. One of them Mercedes Smart, one of them Guncel, one of them BMW i3, Mini Cooper, and Renault Zoe. This is called as a light electric vehicle. For example, like your final project, we want to design a small electric vehicle for city condition. In first step, I need electric vehicle design. Initial design parameters are determined. The targeted design, in this paper, we are calculated the average parameters of these 5 vehicles. Okay. Average of these companies' vehicles, for example, average range for high sale number vehicles, average range, nearly 300 kilometer. Maximum speed for this vehicle as average, don't forget it, 150 kilometer over hour. Electric motor power 110 kilowatt average. Battery capacity 40 kilowatt hour. Also vehicle weight 1350 kilogram. Okay. This is my starting approach. My aim in my design, I targeted the maximum speed 130 kilometer hour. Okay. This is first criteria, maximum speed. Second criteria, maximum slope, 6 degree. Another one, minimum range. My minimum range aim 250 kilometer. Yes, it's important to calculate this. Yes, you can if you select the design criteria, you can calculate your battery capacity, your electric machine type, etc. It is a first starting criteria. Maybe after this course, you can understand the all aspect of the design. Okay. Also, I will upload it. Also, I will upload it. This is my design, but it is hard design because in this paper we are we focus to permanent magnet synchronous machine and field-oriented control. In your final project, I am waiting from you as a mathematical model. Okay, like a mid final homework, like a homework. And another criteria range. I selected the 250. A vehicle weight is important, 1,300 kilogram, and battery capacity 45 kilowatt hour. Okay. Also, vehicle dimensions are important actually, but we can neglect it in your final project. First step, we are starting with the longitudinal vehicle dynamics calculation. Okay. For longitudinal vehicle dynamics calculation, vehicle weight is important. Vehicle weight M 1,300 kilogram. Also, rolling coefficient CR. Okay, rolling coefficient CR. Sorry. Air density, next one, rho, air density 0.015. Also, next one, CD. CD is drag coefficient. It's called. Sorry. Drag coefficient. I select drag coefficient 0.36. It is depend on your road condition. Also, maximum slope 6 degree. Also, gravity 9.8. Well, wheel diameter is important here. Wheel diameter generally 0.594 meter. Maximum vehicle speed is considered at 130 kilometer hour. That's allergic. Oh, sorry. In the morning time, every time, it's allergic. Okay. Summer, actually, it's very easy. First step, longitudinal vehicle dynamics calculation. We have only one formula here. Okay. You need to model in MATLAB, Simulink, this formula. It's very basic, I think. and then you calculate total force acting on the vehicle. Okay, F total. But don't forget it. This is just a force, not torque. It's just a force. First criteria, MA. We know vehicle mass. You select it. A, alpha, you know, acceleration. And then mg, cr, we selected cr, 0.015. You can use these parameters. Cos theta is your slope. 1 over 2 rho is your air density. AF is interesting. AF is your surface of your vehicle. For example, in this study, AF is calculated as a 2.487. Okay. For example, you use like this one. And then vehicle speed square plus mg sin theta. Sin theta, theta is slope. Lateral forces are neglected in this study. I am waiting from you neglecting of lateral forces. Lateral forces are not important for us in the this study. Also, interesting point, slope table. For example, you can see using this formula at zero slope on the flat road, my total force acting on a vehicle nearly 300 Newton. It's very low. However, in 6 degree, your force value goes to 1500 Newton. You can see now why slope is important for us. If you design for flat road, for example, your motor selection is calculated for 0 degree slope, your motor will be very small. However, in the stick condition, for example, 6 degree, your motor is not enough for your operation. I recommend you can select 6 degree slope or 5 degree minimum. Okay. And then this is just a force value. We need torque value. Okay. What's the torque value? Torque value is depend on the wheel diameter. Actually, you can see. What's the formula of them? Force times wheel diameter. Over 2 actually. This is the diameter. In this calculation we are needing radius, force time diameter over 2. Total torque value acting on the wheels is calculated 450 Newton meter to reach the maximum speed of 130 kilometer hour. Okay. Now we know my maximum torque. I need to select a motor for this operation. No, actually no. We need, this torque value is very high. This continuous torque value is very high for a motor. We need gear ratio. This is called as a transmission. I select 4 to 1. What does it mean? My total torque 450. I choose 4 over 1 transmission. What does it mean? This value over this value, it gives us 120 Newton meter. Okay, 120 times 4 will be equal nearly needed torque value. Good. Continuous torque, clear. Speed is important. How can you calculate the vehicle speed? I know vehicle speed. I know diameter of wheel. It's very clear. To the linear velocity, you can calculate the rotor speed. Also, we have a, don't forget it, gear ratio. And then I obtain 4080 800 RPM. How can you calculate the motor power? It's clear. We can write, for example, power torque times omega. You can calculate your motor nominal motor power actually. Don't forget it, continuous motor power. For example, instantaneous power needs you can reach, for example, 120 kilowatt. Okay. To do here, we modeled two systems. Transmission, it's very clear. Transmission is very basic in Simulink. 1/4. Okay. Transmission and longitudinal vehicle dynamic. This is actually motor model, but this is the advanced motor model. We cannot concentrate in this course, this model type. This is called as a permanent magnet synchronous machine. Actually, in your design, we are waiting from you only DC motor, like a DC motor. Actually, they are in the same family, but you cannot use the Q axis and D axis parameter. We will be in the only DC axis. Next stage, state of charge of battery. Here we have a one formula. This is called as a Coulomb counting method. Okay. You can write to Google Coulomb counting method. What's the Coulomb counting method? Coulomb counting method is used to determine the battery capacity. It's not a sensitive method, but it is very important for simple approach. Here you can see state of charge value at the first moment for zero position. Initial battery actually, it's initial battery charge rate, for example, 100%. And then IT BAT, it's very easy, battery current. For example, you design a motor in the Simulink, first homework, remember, you have a current value for your motor operation, you remember, this current value times time, you need to convert it kilowatt or watt hour. Your initial battery is meaning that in the study 45 kilowatt hour. How you can calculate the kilowatt hour value? Current times voltage times time. If you calculate initial capacity minus every moment power, not power, energy value, you need to calculate the instantaneous state of charge value. This is called as a Coulomb counting method. I recommend you Coulomb counting method. Your final project model actually like this one. Wait me. Vehicle longitudinal model. It's just an one formula. I explain it. Vehicle transmission model 1/2. It's only just one number. Battery model Coulomb counting. This is in your project. DC motor. You design actually. You have a speed reference. You have a speed output, measured speed. Next one, NEDC driving cycle. In the MATLAB Simulink, NEDC driving cycle is this. It is using for vehicle performance calculation. Time and speed value are changing. This is your reference speed value. In the Simulink library, you can find an EDC driving cycle. You cannot design it. Only you will add it. And then I am waiting from you in final project, rotor speed variation, motor torque variation, electric machine power. The most important one, I think, battery state of charge variation. If we can apply an EDC cycle, my initial battery state of charge 1, it goes to 0 nearly 95 state of charge. Also total distance traveled, like this one. This is my controller response and battery current variation. Okay. Do you have any questions somewhere for project? I think it's clear. Yes. Yes, you can ask. Ah, okay, okay. And then oh, it's a good course. We can finish today somewhere. Happy New Year for you. Thank you for your attendance to the course. This is like a special course, one-to-one. Thank you. Uh, Happy New Year, your family, for your life, for your future. A good year. Thank you. We can finish it. If you have a question, please ask me in the next week, in the final week, etc. Also, I will organize one or two makeup class. I will announce it after this week. Normally, we are completing our courses today, but we need the two more course. I will announce it. Please follow the email. Okay. Thank you. Happy New Year. Bye bye.